Good morning, grade 10. We are still in the activity part of module 1, okay? Weeks 1 to 4 for the second quarter, which is EM waves, right? But I think we need to hurry up, speed up, simply because your examination or your second quarterly examination is fast approaching. That will be next week. I think 16 and 17, if I'm not mistaken, or 17 or 18, okay? We'll be sending the schedule hopefully this afternoon or by tomorrow, right? Did your advisor already given you the coverage for the second quarterly exam, everyone? Did your advisor send it to you in your GC? Yeah, okay. So again, the second module is actually included in your second quarterly exam. That is why. So we need to hurry up. But of course, we need to continue with the activity. So what we're gonna happening now is you'll be answering the activity for today, which is activity number 4, EM waves visibility, and we'll be having a continuation of the discussion in module 2, weeks 5 to 8. Would that be okay? Everybody, would that be okay? All right. So let's have the module 2. Welcome to the module 2 for second quarter, weeks 5 to 8, mirrors and lenses. Okay, what's the mirrors and lenses? What are the usability? How can we use this one? How are we affected with this? And what are the practical applications of these mirrors and lenses? Okay. Microscopes, okay? With the lens, microscopes let us peer inside invisible worlds our eyes could never see. Telescopes take us far beyond Earth and stars, okay? And planets of the night sky. Movie projectors throw enormous images onto screens, and lighthouses cast reassuring beams of light far across the ocean. Amazing curves of glasses or glass or plastic are called lenses, okay? Make all these things possible. Let's take a look at a closer look on how they actually work, okay? A lens is a transparent piece of glass. It is actually a transparent piece of glass or a plastic. Some of the glasses actually, the eyeglasses are made out of plastic, but as clear as a glass, okay? It gets its name, okay, from the Latin word lentil. This is a type of pulse used in cooking, but don't let that confuse you. There's no real reason for this other than that most common kinds of lens called the convex lens looks very much like a lentil, okay? Have you seen a lentil? This is actually a lentil, okay? It looks like a curved bean, and again, it looks like a convex lens, okay? A lens work by refraction. What do you mean by refraction? It bends light rays as they pass through it so they can change direction. So bending of light or light rays is called refraction, okay? That means that the rays seem to come from a point that's closer or farther away from where they actually originate. And that's what makes objects seen through the lens seem either bigger or smaller than they really are. A lens produces a focusing effect. It depends upon the lens also, because light travels more slowly in the lens than the surrounding air. So that refraction, an abrupt bending of the light beam, occurs both where the beam enters the lens and where it emerges from the lens into the air. Okay, just like this one. So if you're going to look at this, we have convex and concave lens here. Okay. You look at the direction of light as it passes to the convex lens. This is the concave lens, okay? Converging lens, because it actually converges. So we have a focal point. If you're going to look at this one, we have a focal point, a focus, okay, of the image or the light, okay? While the convex lens, the concave lens rather, it is called diverging lens. Diverging because it scatters the light, okay? It scatters the light, or it scatters the image. So let's take a look at the effects of these lenses, okay? And the practical applications. Types of lenses, okay? There are two main types of lenses known as the convex or the converging. Converge, okay? Meaning to say that it has a focus because it converges. And concave, which is diverging, diverge, separate, okay? Convex lens, sometimes called the positive lens. The glass or plastic of the surface bulges outward, just like your eyeglasses. In the center, giving a classic lentil-like shape. Okay, a convex lens is also called the converging lens because it makes a parallel light rays passing through it bend inward and meet or converge, okay, at the point or spot just beyond the lens known as the focal point. Okay, it has a focal point. Again, in your exam, if it is asking about a lens with a focal point, it is actually a convex lens. Okay, this is a convex lens. It has a focal point. Okay, when light travels in there, it now creates what? A focal point, just like your magnifying glass. Have you seen a magnifying glass? Have you seen a magnifying glass, everybody? Okay. Just like your magnifying glass, it creates a focal point. Okay? It creates a focal point. So meaning to say that in that certain area, the light is being concentrated. So that is the reason why if you're going to use a magnifying glass under the heat of the sun, it can actually cause burns, or it can actually cause fire. Why? Because you're using a convergence lens or converging lens or a convex lens. Okay, doing that so can create what? A concentration of heat. Okay, you are concentrating the solar energy into a particular focal point. Convex lenses are used in things like telescopes, binoculars, to bring distant light rays to a focus in your eyes. Okay. How about concave lens? Okay, what's in the concave lens? It is exactly the opposite, with the outer surface curving inward. If convex lens, the curve is outward. And on the other hand, concave lens, the curve is inward. So it makes a parallel light rays curves outward, or diverge, or separate, or scatter. Okay, that's why concave lenses are sometimes called diverging lens. Converge and diverge. Okay, one easy way to remember the difference between concave and convex lens is to think about concave lenses caving inwards. So there is an inward what? An inward outlook of this lens. So if you're going to observe a concave lens, you can actually observe an inward, this one, okay, an inward outlook of the lens. Okay, so since this lens has an inward, okay, an inward appearance or an inward outlook, it scatters light. Okay, it scatters light, it diverges light, right? Concave lens or lenses are used in things like TV projectors to make light rays spread out into the distance. In flashlight, diba? When you're using flashlight, you're not concentrating the light, you're actually scattering the light, right? It's easier to do this job with a mirror, which usually weighs much less than a lens and is cheaper to manufacture as well. What else? your projectors, your DLPs or digital light projectors, it is actually using, or they're actually using concave lens. Compound lenses. It's possible to make lenses that behave in more complex ways by combining convex and concave lenses. It is actually compound. It is a combination between convex and concave lens. A lens that uses two or more simpler lenses in this way is called a compound lens. Okay, again, compound is a mixture or combination of a convex and a concave lens. The power of lens. Okay, if you ever look to a binocular or a telescope or a magnifying glass, you know that some of these lenses can magnify, or some lenses magnify or reduce the appearance of an object as much as more than others. There is a simple measurement that tells you how powerful a lens is, and it's known as the focal length. Okay, we also use, as me as a photographer, I usually use also focal length. Okay, focal length in determining the distance of, or the capacity of my lens. Okay, camera lens, right? The focal length is the length is a focal length of a lens is the distance from the center of the lens. Okay, we're looking at the center of the lens to the point at which it focuses light rays. The shorter focal length, the more powerful the lens is, right? Okay, it's easy to see why an ordinary piece of glass would look like a lens of infinite focal length and wouldn't bring light rays to focus at all. On the other hand, an infinitely powerful lens would bring rays of rays to a focus in an infinite short distance with zero focal length. Okay, a real lens is somewhere between these two extremes. Okay, it can bring the far, okay, far object near, or it can bring the near object far infinitely. Okay, do you have any questions so far? Questions?
Yeah.
Okay. Right? You'll find focal lengths written in either ordinary units of length such as centimeters, millimeters, or inches. Okay. In our case, in lenses, which we have right here, a camera lens, we're using millimeters. Okay. 35 mm, 50 mm, 105 mm, 18 to 105 mm, 400 mm. So those are the way how we actually what check on the length of our lens, or in special optical units called diopters. Okay, the diopter measurement of a lens is a reciprocal of the length in meters, one divided by the focal length. So one diopter is equal to 1 meter. Okay, or two diopters is equal to 0.5 meters, and so on. Eyeglass prescription from the opticians typically show the length of the corrective lenses you need in diopters. Just like in my case, I am using a I think this is 122 or 120. Okay, 120. So in my lens, in my glass or glasses, the focal length isn't the only important feature of the lens. The bigger the lens, gather more light, or the bigger the lens, it gathers more light than the smaller one. So they make a brighter image. This is particularly important if you're choosing a lens for a camera. Correct. Okay. In a camera, if you want a clearer image, if you want the best image, you need to have a bigger lens also, because the bigger lens gathers more light. And photography is more on light, right? If there is no light, there is no photography at all, because images are based on the captured light, right? Will determine what the image looks like. Camera lenses are usually rated with a measurement called f or focal, f number, which is the focal length, okay? Divided by the diameter. Generally speaking, lenses with small f numbers make brighter images, okay? Because it's different thing when you're talking about the focal length. Okay, the smaller the number, the bigger its what? Its opening, okay? The bigger the number, the smaller its opening. So it's reciprocal, okay? Lenses with a higher f number or focal number have the bigger depth of focus, essentially more of the object you're photographing and its surrounding are in focus at the same time. So again, if you're going to open the focal length, the smaller the focal length, so it's bigger, the opening is bigger, so you cannot actually focus at all. It will just focus on a particular area. But if you have the bigger focal length or focal number, okay, tendency is it can actually focus more on the subject. But smaller light, of course, because again, the bigger the number, what? The smaller the opening. So it actually what? What is the effect now? Smaller light will come in, but it focus more on the subject. The uses of lens. Lens are everywhere in the world around us, and in everything from car, headlamps, flashlight, to LED lights, used in electronic instrument panels. Our eyes contain probably the most amazing lens at all. Okay, again, the most amazing lens. For me, it is the most amazing lens. Think what happened when you look at the world around you. 1 minute, you're staring at the ground in front of your feet. Okay, so it looks like the demonstration here looks like how your eyes focus. Okay, you can actually focus on something, and if you're going to observe the surrounding or the environment of your subject, the one that you are actually focusing, it becomes blur, correct? And if you focus on your background, it will return to its form. So meaning to say that our lens or our natural lens has a bigger focal point. Okay, it has a bigger focal point, focal length rather, and of course a smaller f number or focal point. Okay. Seconds later, you hear an airplane screaming past, and you turn your head and you watch it fly by. Do this trick with a pair of binoculars, and you'll find it takes you quite in a while to adjust the focus from the near side. Okay, looking at the ground to far watching in a plane. So remember that it is a two mechanism. Okay, when you are actually looking near from you, it focuses fast. But it is if you're looking far, your eyes usually what? Focuses also. Okay, it adjusted itself. It adjusted its optical nerves to particular situation. So that's how great our eyes, our lenses. Tie it to the naked eye and you won't even notice what you're doing. Correct. You don't even notice that you are focusing something. That's how great our lenses, okay? Our natural lens. That's because your eyes have flexible lenses controlled by tiny muscles, which is your optic nerves, that can bulge in and out, changing shape instantly to focus on anything from the prints on your finger to the surface of the moon. So if you're going to observe, if you're really highly observant with your eyes, if you're going to expose your eyes in a very light condition, okay, very light condition, your retina will actually close. It will become smaller because too much light are coming in. Okay, but if you're going to expose yourself in a dark room, okay, your retina will open wide because it needs more light to see. That's how great our eyes, our lens. We all have lenses in our eyes, but many of us balance extra ones on the other on end of our noses to correct long and short sight. More glass or plastic lenses are used for eyeglasses and contact lenses than for any other purpose. Okay, there are all kinds of glasses or glass lenses, including light sensitive or photochromic ones that darken in sunlight and double up as sunglasses, just like what I'm wearing now. If you're going to observe it, if light passes through it, it will become blue or it changes its color simply because it is light sensitive. Okay. If I'm gonna expose this under the heat of the sun, it will actually darken. Okay, because again, it is light sensitive. It protects your eyes from the danger of electromagnetic waves, your radiation. You also find lenses in binoculars, which use 2 or more lenses in each of the cylinders serving your eyes. The telescopes, though not all microscopes use them, ordinary optical microscope use the series of glass lenses to magnify tiny object. Okay, it uses a series, meaning to say a lot of lenses, okay, to magnify tiny things, tiny objects. While superpower electron microscope use electromagnets or electrons to bend electron beams that help us see even more in detail. Movie projectors and projection television use lenses to convert small movie pictures into giant images that lots of people can view at once. Okay, cameras work also the opposite way, catching light rays from the distance and bringing them to the focus on chemically treated plastic film and light-sensitive electronic chips or CCDs. In this case, we are not actually using now. We are in the modern world, so we are using a data chips, okay, instead of CCDs. Okay, we're using data chips. We're using SDs or storage drives. We're using also micro SDs in our camera, even in our phone, that actually captures the image. Printing is more on digital as of the moment now, but some of my photographer friends, they actually want to recover the film because that is actually the essence of photography. It's in the film. Okay, you can even find lenses built into magazine and book covers to make images change as you shift your head from side to side. This cunning trick is called the lenticular printing, but it really just means printing with a built-in lens. So if you go, have you seen this one? Like if the image is in front of you, it has it has a still image, but if you're going to switch it over, it changes its appearance. So that is actually the lenticular printing. Okay. Mirror. Let's move now to mirror. Do you have any question with the lenses? Question with the lenses? Question? Anybody?
Mm,
Dimitri, Margie, and Holly?
no.
All right. Mirror. The law of reflection says that when a ray of light hits a surface, it bounces in a certain way, like in a tennis ball thrown against the wall. The incoming angle is called the angle of incidence. Okay? The incoming angle which light reflects on or bounces on is called the angle of incidence. Okay? Is always equal to the angle leaving the surface or the angle of reflection. When light hits the surface at a low angle, like on the lake at the sunset, it bounces off at the same low angle and hits in our eyes full blasts rather than obliquely as when the sun sits overhead. Okay, This is why sun's glare during the evening and the morning is so much more intense than during the rest of the day. That's the reason behind. Because again, it actually hits our eyes in a full blast. Okay? Light itself is invisible until it bounces off something that hits in our eyes. For instance, a beam of light traveling through the space can't be seen from the side until it runs into something that scatters it, okay? Like a cloud of hydrogen or a satellite. The scattering is also known as diffuse reflection. And this is how our eyes interpret what happens when the light hits an even surface. Okay, we still have 7 minutes more. I think we need to continue by next meeting simply because we still have an activity to do. Again, please I'm reminding everybody. Can I have, wait, Holly, are you still with us? Holly, is Holly around? Is Holly around, everybody? Okay, let's have Margie. Margie, are you still with us? Margie? Okay. Margie, can you please inform your classmates, okay, those who are not here, that we have activity for today, okay? The activity for today is activity number 4. Let me share it again. Activity number 4, the EM usability. Okay, you need to do this today simply because it will close today, okay, at 5 p.m. I know that you are doing, Margie, this one in the module, but please inform your classmates. That's the least that we can do in order for us to help them, right? I know that you're doing this in the module. Direction is determine the usage of the following electromagnetic waves. Type your answers in the space provided, right? Margie, can you do that for me? Right? Right. Do you have any questions so far? Questions? We're done with the lens. We are now moving on by next meeting with the mirrors. Okay. I think that will be all for today, class. Again, please do your activity number 5, number 4 rather, which is the EM waves usability. Have a nice day, grade 10. Take care. Bye-bye.
Bye-bye.